In this video we are going to learn about neural networks. So already through my past videos you must have gotten some idea about machine learning and how machine learning can impact our day-to-day lives. So deep learning is another type of learning or a form of machine learning that uses neural networks to learn. And the artificial neural network is inspired by biological neural network where each neuron, that is the combination of cell, dendrites or action. So let me show you one picture about it. So which is a combination of cell body, dendrites and action. So these are the drivers of various computational abilities of human brain. So if you see in figure A, each in each neuron, the inputs are collectively accepted by individual cell body, by dendrites, and produces output signals along its action branches. The action individually branches out and connects via synapses to dendrites of other neurons. So through these actions branches, it is again connected with another one neuron. The basic components of ARN is given in the that is the artificial neural network. So it's given in the figure B, so which consists of 6 components: the input layer, then the weights, the hidden layer, the summing function, the activation function, and the output layer. So what happens actually in the input layer? So the input signals such as x1, x2 up to xm are sent to input layer, are transmitted to the next layer. The synaptic weights including bias, so which is signified by WK1, WK2 or WKM. So it refers to the strength of connection between two nodes. And hidden layer, so hidden layer, these are the intermediate layers providing information exchange between input and the output layers, and these are called hidden layers. The network can result to effective outputs if there are enough hidden layers in between the input and output layers. Then next comes the summing junction. So it is a merging junction that calculates net input to a cell. The bias can be applied at times which is used to adjust the output. Along with the weighted sum of inputs to neuron, this helps the model to be best fit for a given data. Now next comes the activation function. It determines the output that the cell produces in response to the input by processing the net input from the summing junction or summing function. Then last is our output. So here the information to which an appropriate activation function is applied is processes to produce output required for input data given in the first stage of the network. So artificial neural networks are inspired by mostly the biological neural networks, and each neuron, so this is a basic structure of a neuron, and the neuron receives inputs and fires if the inputs exceed a threshold. Now I'm going to show you some of the real world applications of this. So the ARN or artificial neural network is mostly used or applied in financial modeling in case of prediction of stock market, in climate, weather, for time series data prediction. Then some of the computer games such as Intelligent Agents, Chess or Backgammon. Then in case of robotics, for pattern recognition and analysis, let's say for speech recognition, you have seen the speech recognition in our previous videos as well. So then next comes data analysis in case of data comprehension, data mining or data science. and it is also used in case of DNA sequencing, such as in your bioinformatics. These are some of the real world application of it. Next, we are going to learn about a perceptron. So, what is a perceptron? So, to build up towards a useful multi-layer neural network, we will start with considering the not really useful, the single layer neural network, and it is also called as perceptron. So, perceptron consists of a single neuron that fires if the sum of the weighted inputs exceeds a threshold, and the bias term is here actually B. So the output is set to 0 if the weighted inputs Wi, Xi, the summation of all of the weighted inputs is less than B, 1 if the summation of the weighted inputs are greater than or equal to B. And here summation of weighted input is to be calculated in this way. So here actually the input is a multidimensional and the input can be a vector. So input X is termed as X1, X2, X3. Input nodes or units are connected typically fully to a node or multiple nodes in the next layer. A node in the next layer takes a weighted sum of all the inputs. So the summed input is termed by in this way, summation of Wi, Xi. Then the output node has a threshold or bias termed as B. So the rule is that if the summed input is greater than or equal to then it fires the output 1. So it's always based on the bias term. Else, that is, if the summation of weighted input is less than the threshold value or B bias value B, then it doesn't fire and the output will be 0. That is what a basic structure of perceptron is. Next, this is a single perceptron and it is a linear classifier. So actually what happens, a perceptron is usually used to classify the data into two parts. So therefore it is called as linear or binary classifier. So in this picture, as you see, so the output red or the blue depends on the bias value of 5. If it's the value is greater than or equal to 5, then it is red output, blue if the result is less than 5. So here x0 values are -2 and here x2 is 1 and the bias value is termed as 5. So based on this formula, we are going to decide the output value. So based on multiple input values in a given data set, if the data can be classified linearly as shown in the picture. So these are the red values in this hyperplane. Top part signifies our red outputs and the below part, down part gives our blue outputs. So then it satisfies the linear classifier properly of a perceptron. Next, we are going to see what is a multi-layer perceptron. So actually, a single layer perceptron SLP is a basic type of artificial neural network that consists just of two layers of nodes. An input layer containing input nodes and an output layer containing the output nodes. That's a simple or single layer perceptron. But let's say we will consider a multi-layer perceptron, then what happens to the structure? So in case of multi-layer perceptron or MLP, so it introduces one or more hidden layers in between the input and the output layers, giving them the ability to learn non-linear functions irrespective of this linear one. So if you see, it consists of an input layer. So input nodes are x1, x2, x3, xm, and an output layer y. So these are all fully connected. All the input nodes are fully connected to all the hidden nodes. And each node in a layer connects to all node in the next layer. So input node x1 is connected to all the hidden layers. Input node x2 is connected to all the hidden layers, and so on for x3 and xn. And each hidden node uses a non-linear activation function that outputs the value between 0 and 1. So whether the output will be 0 or 1, it's basically depending on a non-linear activation function like our bias or the threshold that we saw in the previous slides. So our previous single layer perceptron was not able to read the non-linear relationship, but here multi-layer perceptron has the ability to learn the non-linear relationships. It is also called as a feed-forward ANN, that is artificial neural network, because every input from the input node is to be fed forward to the other hidden nodes, then the output is determined. Next, the training the neural network. So what is this? So here the weights and the bias terms are updated during the training process. So there is a loss function. Loss is often used in training process to find the best parameter values for our model, that is the weights in the neural network. So it is what you want to try to optimize in the training by updating the weights. This is your loss or the cost function. Then there is another one term called epoch. So an epoch is a measure of number of times all the training vectors are used once to update the weights. For batch training, all of the training samples pass through the learning algorithm simultaneously in one epoch before the weights are updated. So if you want to have more idea about this, please go through this YouTube link. It gives a good general overview about the neural networks and how to train them.